What's up, everybody? Today we're going to be talking about impulse and how it relates to jumping. This is literally the most important physics equation because it has a direct one-to-one correlation to vertical jump height. So the higher your impulse, the higher you're going to jump. And everything we do in terms of training and jump technique is geared towards maximizing impulse. So when we look at impulse, it is a change in momentum. So think of momentum as how big something is, how much mass it has, multiplied by how fast it's moving. So if you take a semi truck that's moving at 100 miles an hour, it's going to have a lot more momentum than a bicycle that's moving at 5 miles an hour, right? It's got mass and speed. Now, a change in momentum is your final momentum. So that's the final speed that you're looking at. So when it comes to a vertical jump, that's toe off. So right when you're the final frame that your feet are on the ground, that's your final velocity at toe off. So your moment, and then your momentum is how heavy you are multiplied by how fast you're moving up. So that's your final momentum. And then your initial momentum is when your block foot hits the ground. So your plant leg. So it's your plant leg, then your block foot, toe off, right? How much momentum you have at touchdown of the plant leg is your initial momentum. And then impulse is force times change in time. Force is self-explanatory. That's just how much force you're applying into the ground when you jump. The change in time is the change in time from the first frame that your plant leg is hitting the ground to the last frame that your block foot is on the ground for, is equal to the final momentum minus your initial momentum. All right. The other variable that is directly correlated to how high you can jump is final velocity. So when we look at kinematics, that's a set of equations that measure the basically things being in the air, airborne things. They show that vertical jump height is directly related to final velocity. So the faster you're moving at toe off, the higher that means you're going to jump. And we can derive this equation right here to equal final velocity. So again, this is how much force you're generating. This is how much time you're on the ground for, your ground contact time. This is how much you weigh. Initial momentum is your momentum at touchdown of the block foot. So think about all the speed you just generated from your approach, and it is negative because you are applying, because it's a eccentric force. It's a negative force. So, and then right here is your mass. So the less you weigh and the more force you can apply, the higher you're going to jump. However, it's subtracted by your initial momentum. So why even worry about having a fast approach speed if it's just going to subtract from your force times time over here, right? You're going to have a lower number and your final velocity is going to go down. It's because the faster your run up, the higher the peak forces are on your approach. And the reason that is because we are using some magical thing called eccentric muscle contractions. And eccentric muscle contractions increase in force the higher you are moving. This is due to a more pronounced stretch reflex, inhibition of the Golgi tendon organ, more fast twitch motor neuron recruitment, and the tendon having more stored elastic potential energy because you're stretching it. Higher eccentric forces stretch the tendon. Eccentric is a lengthening motion under tension. And then the bigger that stretch, the bigger the release, the subsequent release in energy, because the musculotendinous unit, so that's your muscle and tendon, it is elastic. And elasticity is a material's ability to return to its normal length after being stretched. So the MTU is elastic, so the more we can stretch that tendon, well, that musculotendinous unit, the more force is going to be, the more energy is going to be released and the more force is generated after that eccentric muscle contraction. So higher approach speed, you have higher negative momentum, so it decreases this top number, but the resulting change in force is much bigger than the change in negative momentum here. All right. Now there are some other downsides to having a fast approach speed. It's not all about just running faster, because if you run faster, it's going to be a lot harder to coordinate your limbs and your legs with it's harder to time the movement, basically. Your arm swing, how your legs hit. Also, if you're not strong enough to handle that approach speed, all that extra energy that you built up is going to be released as heat. So that's why we do those eccentric cycles, the super maximal eccentrics and the maximum effort isometric cycles. We want to get really strong eccentrically and isometrically so that we can handle those higher approach speeds, so that we can convert all that velocity into vertical velocity, all that momentum that you have going into the jump. All right. Let me make sure I covered everything in here. Minimizing ground contact time. So if you see the time variable here, it's at the top of the equation. So that means that the longer you're applying force for, the higher your impulse is going to be, the higher your final velocity is going to be, the higher you're going to jump. So why do we always, for one, that explains why we want a long penultimate. Remember, a long penultimate, the whole purpose of that is to lower you. Why do you want to be low? Is because the lower you are, the more time you have to apply force into the ground. If you're at a quarter squat, so this is a half squat, this is a quarter squat, right? If you're in a quarter squat, you can only apply force, assuming the motion velocity is the same, from here to here, right? Let's say that takes 0.1 seconds, versus from here to here at the same velocity is taking 0.2 seconds. That's 0.1 more second that you had time to apply force for, which maximized your impulse, all right? Which made your change in momentum even greater. But a cue that we always give is really fast ground contact times. Make the rhythm of those last two steps really, really fast. Why do we want to do that? It's because that's going to allow you to transfer that horizontal momentum into vertical momentum more efficiently. You're going to have higher eccentric forces. You're going to maximize force. But speed isn't always better. Speed isn't better when you're a beginner because of the coordination problem. And then speed might not be better because you might not be strong enough to handle those forces, okay? And an example I like to give is when I was doing my depth jumps off a 60-inch box, this really put it at my top of mind, because I was jumping off a 60-inch box, and then I had a vertex set at 11.6, and I was trying to touch, or 11.4, I believe, and I was trying to touch it, right, off the 60-inch box. There were some jumps where I was smacking it, right? I was getting full palm on it. There were other jumps where I was missing it completely. And the jumps where I was trying to minimize my ground contact time, it was not working out. However, the jumps where I let myself kind of sink into my plant, get into that half squat, and then time my arm swing with the squatting up part of the motion, the higher the jump. So faster isn't always better. But if we give that cue of faster last two steps, there is usually a reason why. You might just be doing it too slow, which means you're not getting a lot of eccentric forces in that jump. So that is impulse and how it relates to jumping. Hopefully that was useful, everybody. I'll catch you guys in the next lesson, whenever that is.